Welcome to another video, the same every time. IGCSE Maths and GCSE Maths, looking at the kind of questions that, apart from the numbers, are the same every time. In this set of videos, we're looking at speed time graphs. So, what have we got here? An actual exam question. Abdul draws this speed time graph for a journey. The graph has 4 sections, A, B, C, and D. Speed meters per second on the vertical axis, time in seconds on the horizontal axis. It's always worth checking right at the beginning that the units for the time are matching up. Seconds matches with seconds, which is exactly as it should be. Let's have a look what's going on here then. Complete these statements about the speed time graph. Section something cannot be correct. So one of these sections is wrong. Section something shows constant speed and section something shows deceleration. Well, I'll give you a few seconds to think about that, or you can pause the video, but I'm going to fill it in now. So I'll start from the bottom question. I think section something shows deceleration. Remember, it is the gradient, the slope of the line that shows acceleration and deceleration. So acceleration would have a positive slope like that. Speed is increasing as time increases. Deceleration has a negative slope like that. So which part of the graph has a negative slope for deceleration? Part C, I think, isn't it? Constant speed. Well, the acceleration would be 0. If the speed is constant, then the acceleration is 0. The speed is not changing. Remember, acceleration is a measure of the change in speed over the change in time. So where is the speed not changing? We're looking for a horizontal line. So section B, a horizontal line on a speed time graph, shows constant speed. One of these sections cannot be correct. Well, section A can be correct, can't it? Over the time from 0 to 30 seconds, speed has increased from 0 to 10 meters per second. B is the constant speed, that's fine. C is the deceleration. Right then, what about part D? The problem with part D is that our journey, we're going to be increasing the speed to there, then the speed remains constant, and then the speed decreases. Well, now we're at 100 seconds, and then we're going back to 90 seconds. So we can't go backwards in time. Everything, of course, the time has to be moving forward. So section D cannot be correct because we are moving backwards in time. Now we're back in more familiar territory. So section A shows acceleration of something meters per second squared. So they are asking us to work out the acceleration in section A. So there's section A. Acceleration is the slope of the line or the gradient of the line. So change in y divided by change in x, or rise over run. So 10 is my rise or my change in y, and 30 is my change in x. So change in y divided by change in x. 10 divided by 30. Okay, 10 divided by 30, that gives us, of course, 1/3. So I'm going to write that down as 1/3. I'm going to leave that as an exact answer. But I think because we're dealing with meters per second, I'm just going to round that to 3 significant figures, so 0.333 meters per second squared. I've covered myself there, really, haven't I? I've shown my calculation, 10 divided by 30, and I've simplified that as 1/3 and 0.333 meters per second squared. I think it's more usual, isn't it, to give acceleration in these real-life context type questions to use decimals than fractions, but I think I've covered myself and I'm fairly sure I've got the marks. So the distance traveled in the first 30 seconds. So they only want the distance traveled in the first 30 seconds, not the whole of the journey. The whole journey is impossible, isn't it? Because part D is impossible, but they only want the first 30 seconds. So it's this part of the journey here, And remember, distance traveled is the area under the graph. So it's the area under this triangle. So base times height divide by 2. So 30 times 10 divide by 2. And that's going to give me 150 meters. Always worth checking that they are asking for the units that we actually get. So meters is what they're asking for. And our answer, if our speed is in meters per second and our time is in seconds, our units are going to come out in meters. In this kind of question, of course, sometimes they could ask us to change from one unit to another. Thank you very much for watching. If the video has been useful to you, then please do like and subscribe. I will return with the next video.